see the melting point of some of the molecules. See, for example, carbon dioxide, see sodium chloride, magnesium oxide. Okay, you can see the table. Let's see how it is coming. From the table, it is clear that for carbon dioxide it is minus 56. For water, sodium chloride it is 801. Magnesium oxide it is 2852. So diamond it is 3550. Silica it is 1610. Iron 1535. Copper it is 1083. So the molecular substances it is having very less boiling point. But on the other hand, sodium chloride and diamond it is having very strong and very high boiling point. Okay. So the reason is the reason is it is having a repeating units of structure with a very strong force of attraction between that, and that is the reason why it is having very strong boiling point. And now you may tend to ask a question whether the metals are also having a very high boiling point. Let's see. Let's look into that case. Let's see the closer look of metals and how the electrons are able to move freely through the metal. See, for example, let's take the case of Cu2 plus. Cu2 plus is having two electrons again. Cu2 plus it's having, this is actually not Cu2 plus, it is a copper metal, sorry. So again Cu2 plus, so again Cu2 plus, again Cu2 plus. So this in between Cu2 plus ions, there are these electrons. Actually this is, we call it as a mobile electrons or metallic electrons. Okay, it is also called the mobile electrons, it is also called the metallic electrons. These electrons are, suppose if you are taking a iron circle, so these electrons, it is very freely, it is able to move through the metal atom. Okay, it is very freely able to move through the metal atom, and we call this as mobile electrons. Okay, this is actually nothing but the mobile electrons, and also called, you can also call it as a metallic electrons. So see, these Cu2 plus, actually this is if I draw in this way, this is, so you can write in this way. See, this is a metal atom. This is Cu2 plus. These are electrons. So these are electrons. So in this way, it is being arranged regularly. Okay. So this is this way of arrangement of metallic ions, metallic atoms. We call it as a lattice. Lattice. So due to that, these Cu2 plus ions, or let it be any metal atom, that is very fairly bound, and it is very tightly, it will be bounded. So like these things, it is these mobile electrons, it is very able to move, and that can fetch electrical conductivity to these elements. Okay, and moreover, it is arranges in the form of a regular lattice. It is arranges in the form of a regular crystal. And mostly it is actually the metal atoms, it is something like a grains. Okay, it is like a metallic grains, we call it as a metallic grains. Okay, so, and the metallic bond, it is the, like the metallic bond, it is the force of attraction between this metal and this electrons, I mean like the mobile electrons. The force of attraction, because electrons are having negative charge, and this metallic ions, it is having positive charge. So the force of attraction between both, it will be it is supposed to be negative and positive, that binds it together, right? Okay, explain some of the properties of metals. See, metals are having very strong boiling point and melting point. So it is very difficult to break the force of attraction between these metals and metallic electrons. We call it as because the force of attraction between both, it is going to be very strong. And for example, the copper, it is having 1083 degrees Celsius, and nickel, it is having 1455 degrees Celsius, and sodium it is having 98 degrees Celsius, and mercury it is having minus 39 degrees Celsius. Okay, and now metals are malleable and ductile. See, malleable means you can, if you press a metal, you can make it into sheets. And ductile, you can make it in the form of a wire. Okay. So malleability means you can press it in the form of a sheet, and ductility means any metal you can if you make it, it will be in the form of a wire. So the ability of a metal to form sheet, it is called a malleable, and it is to form wires, it is called a ductility. So metals, if you take a hammer and if you put it, it will be just like a flat. So that is actually that is one of the very good property with the metals. Metals are it is a very good conductor. The reason is, see, why it is able to conduct electron is, see, it is having mobile electron, right? So if you are heating it, this electrons, it take up the energy, and it will move. It is supposed to move, and it just moves, it take up the energy and it moves in one particular direction. Okay, and not particular direction, it moves in all direction. Due to that, it can take up the energy, and it can it is able to conduct electricity in a nicer way. Okay, actually most of the metals, it is electrically conducting. Electrically conducting. See, for instance, this is a metal. So, there is free electrons associated with actually this metals, right? So, if you are applying some positive and negative terminal, okay, so it takes up the charge, and this charge, it moves in one direction. So this electrons, because of its flow, it is supposed to move in one direction, and that charge and all, it take up the charge, it will take up the electricity, and it will be carrying the charge. It moves in one particular direction, and due to that, the metals, this mobile electron, due to the presence of this mobile, you can also call it as metallic electrons. Metallic electrons, so these particles, it carries the charge. It carries, and the electrical conductivity will be there.